Welcome to our English class. This year we chose to discuss about some topics, physics, mathematics, chemistry, all in English. What kind of topics did you choose?
I'm going to show how to solve a classical problem of projectile motion. In order to solve a classic situation and classic problems, we're going to give some examples. We are considering a cliff, and we are considering a ball that is kicked from the edge of this cliff. This is the initial velocity, v sub 0, and the angle theta is 0 degrees. So the path will be like this. In this situation, we have just a horizontal component for the velocity, so there is no vertical component for the initial velocity at all. In another situation, we have the angle theta, which is 90 degrees. In this case, the projectile will go straight up and returns back down without moving on the sides at all. In general situation, we can consider the ground and a projectile that is thrown into the air with this initial velocity v sub 0 and this angle theta. For example, we could assume that v sub 0 is equal to 30 meters per second and theta is, for example, 60 degrees. The motion is affected by three factors. In this case, we have the initial velocity, the angle theta that the object is thrown, and the gravitation, the pull of gravity. In a real situation, we have also the air resistance, but in order to solve a classic situation, we do not consider it at all. So we must keep in mind that in order to solve these problems, we should keep an eye to the initial situation. In this case, we are going to solve this vector v sub 0 into its components. So we take our coordinate system and our vector. This is v sub 0 and this is theta. Using trigonometry and the formulas we found before, we know that v sub 0 sub x is equal to v0 times the cosine of theta, which in this case is 30 meters per second times the cosine of 60, which is 30 times a half, which is 15 meters per second. We are now going to find the other component, v sub 0 sub y. V sub 0 sub y is equal to 30 times the sine of theta, which is 30 times the 0.866, because theta, the sine of theta is square root of 3 divided by 2. Which is almost 26 meters per second. We are going to assume also that the G that is acting downward is minus 10 meters per second squared. We are not considering the air resistance. So we now found the two components for initial velocity. Now we'll be asked to find, for example, the maximum height, which is y. We are now going to calculate how much time, in how much time the object that is thrown covers the distance to reach the maximum height. We could use this formula, Vy equals V sub 0 sub y plus A, which is G, times T. So the trajectory of the object will go like this. This is the vertex of the trajectory, which is a parabola, and in this point the velocity, the vector of velocity, will have just a horizontal component. The vertical component is in fact 0. So in this point the velocity is 0, that equals V sub 0 sub y we found before, which is 26 meters per second, minus G, that is 10, times the time we want to find. So the time will be 2.6 seconds. We're now going to find the maximum height. For finding this maximum height, we're considering the formula y is equal to y0 plus v sub 0 sub y times the time plus a half times acceleration, which is g, times the time we found before, squared. So using this formula, we know that y is what we are going to find. So y equals y0 in this case, in this situation, is 0 meters. So we are considering v sub 0 sub y that we found before, which is 26, times the time, 2.6. Minus a half of 10, which is minus 5 times 2.6 squared. Calculating y, and we will find that y is equal to 33.8 meters.